T12.13. In the U.S., there's a strong relationship between education and smoking. Well-educated people are less likely to smoke. Does a similar relationship hold in France? To find out, researchers recorded the level of education and smoking status of a random sample of 459 French men aged 20 to 60 years. The two-way table displays the data. All right, so we have 3 levels of education, primary, secondary, university, and 4 levels for smoking status, non-smoker, a former smoker, moderate smoker, heavy smoker. That gives us 12 cells in the table. We're not counting the totals, but we're just counting the cells inside the table. All right, here's our question. Is there convincing evidence of an association between smoking status and education level among French men aged 20 to 60 years? All right, there's no part A, B, C, it's just the one question. So we're going to use our 4C method, our 4-step process for writing up a response. So the first step is to choose. Okay, and so we're going to write the name of the procedure, the significance level, and the hypotheses. So this is a chi-square test for association or a chi-square test for independence. Either one of those terms is okay to use. Chi-square test for independence. We'll use a significance level of 5%. Right. Our null hypothesis is a statement of nothing, right? So we wanted to say that there's no association, and of course with some context. There is no association between smoking status and education level among Frenchmen aged 20 to 60 years. And the alternative hypothesis is just the opposite of that, that there is an association between smoking status and education level among Frenchmen. Right, so I'm just duplicating the null hypothesis and then just switching one word so that it says that there is an association. Right? So we've got no association and yes association. All right. Next, we're going to check some conditions. So first and foremost is the random condition. We see right here in the second to last line, it says a random sample of 459 Frenchmen. So random, and then we'll just quote a random sample of 459 Frenchmen. All right, next, the 10% rule. Well, it's safe to assume that 459 French men would be less than 10% of all Frenchmen. Of course, we're looking at ages 20 to 60 years. And then finally, the large counts. All right. Now, I definitely don't want, and I don't think College Board expects you to find each of the expected values by hand, because remember, there are 12 cells, so that'd be a lot of little minute calculations. Okay. So the quickest, fastest way to get the expected counts is to use the calculator. Okay. So I'm in the matrix menu, I've gone to the edit submenu, and I'm going to select matrix A. Okay, and then we're going to put the observed counts into this matrix. Okay. We've got to get the dimensions right. We have 4 rows and 3 columns. Okay, so 56, 37, 53, 54, 43, 28, 41, 27, 36, 36, 32, and 16. Okay. All right, and then now what I can do is I can just run the test. So I'm going to the test menu, going to the chi-square test. Okay, so we already put the observed counts in matrix A. We didn't type anything into matrix B. The calculator is going to figure out the expected counts and then auto-save it or auto-fill it into matrix B. All we need to do is run the test. Okay, so we'll come back. Maybe we'll just make a note of this right now. Okay, so the test statistic is 13.3 and the p-value is 0.03. Okay, so let's maybe put the calculate step over here. Okay, so we're getting a little ahead of ourselves, but the chi-square test statistic 13.3 and the p-value is 0.038. Okay. Now my intention here was to run the test and then go back to the matrices and then take a look at matrix B. This is where the expected values are going to be. Okay. And then we're just going to copy them maybe just to the 10th place or something. But the point is we need to make sure that they're all greater than 5. And it looks like they're all double digits. So yeah, it looks like this is going to be met. All right, so just write this out. 59, 44, 50, 37, 42, 31, 34, and 25 are all greater than 5. Okay, I ignored the decimal portion of the number just because I didn't want to have to write a whole bunch. All right, so that looks good. Now we can move on to the calculate step. Okay. So we're going to start with the specific formula. There is no general formula for the chi-square test. So we're going to sum a bunch of terms whose structure is observed count minus expected count squared divided by expected count. Okay. Now, there are going to be 12 terms in this expression, right, because we have 12 cells in our table. Okay. So what I'm going to do is just going to write the term for the top left cell, and then I'll do dot, 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 and then I'll write the term for the bottom right cell. We don't want to write them all out. All right, so this is going to be 56 minus 59.5 squared divided by 59.5 plus dot, 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 plus, okay, and then the last one is going to be 16 minus, let's see what it says on the calculator. Oh, you know what? There was a whole other column. I forgot there were 3 columns there. Okay. So let's go back to the large count. So we missed, there was a 42, 36, 30, and a 24. Okay. My bad. All right. So the last term is going to be 16 is the last observed count in the table, and then 24.3 is the last expected count. 24.3. All right. Let's go ahead and move this over now here. All right, we can draw a picture as well. Just draw a small picture. It's our chi-square distribution. 13.3 would be to the right. Okay, p-value is the area that's shaded. Degrees of freedom. Okay. So we're going to take the number of columns, minus 1, so it'll be 2, times the number of rows, minus 1, that would be 3. 3 times 2 is 6. Okay, so this has 6 degrees of freedom. Okay, the only other thing that I would add in here is the components. There's going to be 12 of them, and we're going to have to run this third-party program called contributions. Okay. So we're going to run it, all right, and then we're going to look at matrix E for each of the contributions to the test statistic. Okay. So let's write this all down. Okay, so we have 0.20, 0.18, 0.04, 0.09. Oops, too far. 1.17, 0.69, 0.64, 1.69. Okay, what did I do? I missed a row. I missed a column again. That looks right. Oh, okay, I think that's it. Okay, so 2.7, 1.86, 1.14, and 2.85. Okay. All right, so these are the contributions. I'll just leave it there for now. All right, let's write our conclusion. So our p-value is about 3%, and our significance level was 5%. So the result is statistically significant. We're going to reject the null hypothesis. We found convincing evidence for the alternative. Right. Since 0.0384 is less than 0.05, we reject the null hypothesis. There is convincing evidence of an association. Between smoking status and education level among Frenchmen aged 20 to 60 years. Now, because the result was statistically significant, we're going to do that follow-up analysis and figure out which of those 12 cells was the most different from its, expected count. So I'm looking at the contributions, and the largest one is the last cell. It's 2.85. I don't see anything larger than that. Okay, and so that's telling me that the number of heavy smokers with university levels of education was, go back and look at the observed counts in matrix B. Was lower than expected, right? So there were only 16, but the expected value was 24. Right, so we'll add this in here. The largest contribution to the chi-squared value was 2.85, and this is because the observed count of heavy university smokers is lower than expected. All right.